world is moving up. There's a outlandish claim that I'm sure many people have a knee-jerk reaction to hearing. So before we get to why I would reason my way to expressing that the world is rising up, we first have to have a wee look at what we're talking about. We see the world, we see movement, we see motion, we see things rising, things falling, and this is how we view the world. We have up, we have down, you know, and we take many of these things for granted, you know, and we have to ask the questions, what is going on? And for me, I'm a very curious person. I have to ask these questions and I have to dig down, and regardless of how outlandish something sounds to you, the knee-jerk reaction would be to hand wave dismiss this. And it's very understandable, coming from where people have been for so long. But I'm going to endeavour here to qualify my position and to hopefully help you progress and have a closer, you know, understanding, a closer relationship with the actual reality that you occupy. Okay? It does seem outlandish. You will have a knee-jerk reaction, but you have to see past that. I am a practical man. I always have been a practical man. I'm not religious. I have no spiritual beliefs, bias. I have no wants for the world to be anything other than it actually is. I only seek to understand myself and the objective arena that I find myself dwelling within. So the investigation is always ongoing, and you know, we seek to find whatever we can. Okay, now I'm going to attempt here to simplify this and qualify my actual position. Okay? There's no need for arguments, you know, people falling out, people having emotional knee-jerk reactions. Reality just is what it is. And if we don't, you know, utilise practical in order to qualify our reasoning, I really don't know where other people are. I can only speak for myself and how practicality is the quality that I look for in regards to an objective investigation. So as we can see, as we look out into the world, you can see clearly from these natural phenomena that we have what we call up, we have what we call down, we have an orientation, okay? We have a vector, we have a top-down situation, okay? Top to bottom, bottom to top. Up is up, down is down. These are orientations of the human being that I'm going to look here to try and clarify, because for me there only is one vector, and that one vector is upwards. Down is only an apparent interpretation relative to an observer. Okay? We have pressure gradient, and as you can see here in this example, we have a density gradient where things are stacked in a particular manner, that being the most dense at the bottom, the least dense at the top. That is your reality, that is observed by everybody, and anything that I offer you here today, you can demonstrate for yourself, you can recreate it, you can cross-reference it, you can review it. I am not interested in rhetoric. I am only interested in you qualifying your position or nullifying my position by way of practicality. Okay? So the things that we're witnessing are due to the presence of force, and that's what we're going to discuss next. Before we get to the claim the Earth is moving upwards, we first have to comprehend some basic fundamental aspects. The very first thing we're going to talk about, and I'm going to hop to the workshop and discuss force before we move on to the real world observations and tests. Hopefully you enjoy, hopefully you learn something and get some clarity from this. Okay, so now we're going to talk about just force quickly. You know, force, if you type that into Google or you speak to many people, you will hear the explanation that force can be described intuitively as a push or a pull. Now, I've been through this many times before. I'm not going to, elaborate too much on that. Push and pull are descriptors relative to an observer. So, in a situation of here being in front of a thing and applying force, motion to the thing, it's described as push. Now, if we're now here on the other side of this and we apply pressure and we bring it in this direction, so we're now in front of the thing, people describe that as pull. Okay? Now, these are relative to an observer, whether something's in front of you and you're applying pressure, or whether something's behind you and you're applying pressure. So as you can see here in this example, we apply a pressure here on the inside and we push in this direction. Force is applied pressure. Motion requires force. Okay? So, we can understand that there is no two things. Only in the minds of people who don't think clearly about these things, they think that force is two different things. Okay? Simply as applied pressure, whether it's in front of you or whether it's behind you. And people bring up many other examples like, tug of war. There's pull because tug of war. Well, again, it's the same principles. You have to first apply pressure. Okay, and now you're going to require friction so that you can now apply pressure in both directions, push in both directions. Okay, there's no two things going on. Push and pull are only descriptors relative to an observer in regards to whether something's in front of you or behind you. So another thing that people are going to bring up, magnetism. Well, magnets pull. So what I'm going to do right now is I'm just going to interject a little couple of videos of Eric Laithwaite and how magnetism is simply the same principles as what I'm explaining to you right now. Magnetism's a flow in a particular direction. Something is flowing in a particular direction that's having an effect on other matter and pushing that matter in a particular direction. Okay? People want to argue about magnetism just for the sake of trying to evade the fact that there is no such thing as a pulling force. And many people have a bias and a want to evade the fact that there's no such thing as a pulling force, because some people require it for a religious bias model, their worldview, a modelling of the world they want the world to be, and they want to make natural phenomena fit their model, so they evade and they avoid certain fundamental principles, like there's no such thing as a pulling force. So I'm just going to throw in the Eric Laithwaite videos here and you can see, and I may throw a little narration over the top of that, and then we can move on.
Why do all these pieces of metal roll backwards along the field? To understand what's going on, we need to look at the shape of the field lines over this motor. They come from a north pole into a south, like that, and the whole field pattern is moving along, like the magnetic river. Now suppose we could sit at one place over the machine, such as in that little square, and watch the field lines go by. Notice the direction of the arrows. At the moment, the field is to the left. Now it's upwards, to the right, downwards, left, up, right, down. So it's left, up, right, down. And the rotation, you see, is clockwise, which is to say, rolling backwards. So the whole machine behaves like a mechanical rack and pinion, in which this is the field and this is the rotor. And here is the action. Well, of course, mechanical things are easy to understand. But when we make it magnetic, it's a little less up.
So what we're witnessing there, the rack and pinion, is a manual push mechanism. All mechanics operate under that principle, all machinery, that one thing pushes upon another thing. Now we see with the flow to qualify what I was talking about earlier and how people like to use magnetism as a justification for trying to invoke some sort of pulling force, we see the same principle. Something's flowing in a particular direction, causing pressure. Now as he removes the manual rack and replaces it with a magnetic one, you're going to see no direct physical contact, but you're still going to see the same principle. Okay?
Obvious, but we put in a row of horseshoe magnets, and the action, as you see, is very similar indeed. This then we call a rack and pinion motor. Of what you've just seen. Instead of a row of coils, we've got a row of rods. We're going to feed them with alternating current so that each one can rise and fall. And when we turn the whole thing, we get the impression of something travelling along. But I want you to notice that nothing actually travels along, because each rod only moves up and down. The thing that makes it real is when we put something into one of the troughs of the wave. Then something real travels along, can make it go the other way.
And you can see in this example of trying to give a visual interpretation of magnetism, the same principle again is applying, where we have a push from the rods going up and down, causing the ball to move in a particular direction.
Watch an individual rod such as this one, you'll see that it's only going up and down. There is no horizontal movement at all. Only the ball is a real thing moving side to side.
So now we are going to move on and discuss the tests and the observations. So I'm going to take it from the start. You know, this particular video here was the result of claims being made about buoyancy and density, or relative density disequilibrium. Now, to understand what I mean by that and what these people are talking about, they're talking about the natural layering that we have in reality, where, as we witnessed at the beginning here when we showed the density tower, so the most dense at the bottom, the least dense at the top, and there appears to be motions going on. And what I mean by appear to be motions, again, I'm going to qualify that there only is one true motion vector, and when we see things falling, i.e. going down, that is an apparent visual thing. What you have to think about here is that people are claiming that there's, again, we've discussed, and it's so obvious for you now, that if we see motion, there's a presence of a force. So particularly when we're talking about something being in a stationary position and then motion happening, there must be the presence of a force. Okay, so what people think is that buoyancy and density, that being dense materials going down and lighter things going up through a particular medium, this is caused by its own presence. That being that the density of a material dictates that it goes down, and the less density of a material dictates that it goes up. Okay, like they have their own directional vector, they have their own source of motion, they have their own internal force, because remember, anything that moves must be in the presence of a force. So what would that force then be? What I was trying to explain to these people is that when we see this displacement and accelerometer, something going through the liquid to the bottom and air at the top, we're witnessing the presence of a force. Buoyancy and density do not exist unless they are in the presence of a force. There has to be motion in order for us to have the separation of buoyancy and density. The displacement only occurs in the presence of a force. So this very first test was a prediction of mine, listening to people claiming relative density disequilibrium. Okay, now my prediction was that when I put this into free fall, that being in the presence of no force, because remember, my postulation is that the force, the motion, is from the earth. The earth's in linear motion upwards. Now, when I put that in free fall, detaching from the earth, my prediction was that nothing has an orientation. This thing which you see now sinking, would stop in its trajectory towards the bottom. I'm just going to skip it forward a little bit here to show you. And I used an open vessel, two open vessels here, and I used this only as a marker to see the relative relationship here, so that you can see a point in which that stops falling through the medium. And if you stop and you pay attention when this reaches here, this is when I let the whole thing go. Again, you can see we're in the presence of a force, there's a displacement happening. Okay? And when it gets to here, I let the whole thing go, removing the force. And we witness no displacement. And as you see, as it contacts Marty, who is attached to the earth, in an upwards trajectory, we now see that force transferred, that motion transfer through the bodies, and now we witness the separation. And again, to repeat and to go to a higher elevation, this drop test was done another 3 times here. Again, the reason being was to demonstrate that buoyancy and density, if relative density disequilibrium was true, okay, that would mean that it's the relationship between the medium, which would be the water in here, and the objects within it. So the separation, that being something rising and something falling within the medium, would be there regardless of whether we are in free fall or not. Okay, but again, and I'm going to keep reiterating it, we only see buoyancy and density, the motion vector, the pressure gradient, when connected solidly to the earth, because it's the earth's motion transferring through the bodies, and what we witness that displacement, that being a gradient. So again, when we play through this video, right now I have it upside down. As I turn, you can see the displacement, the force is present, the displacement is there, and when it's let go, that separation is no longer there until impact. Okay, now I'll just skip forward again just to show you it one more time. So even in these scenarios, as you see, we are witnessing the presence of a force, we are seeing the displacement. And again, as I established earlier, the air will move in the direction of the force, that being the motion, the vector. Okay? And you can see the little air bubble here bouncing about because of the sideways movement. Okay, so again, on these tests we see that the force is now gone. So another aspect here, and I'm going to use various videos, you know, I've done all of these myself and many other people have now repeating them. So I'm going to use real world Marek's little video here because it has 2 aspects that I want to just quickly discuss. I'm also going to use some of William, and I'm going to use some of Andrew's videos coming up very soon. So what I want to show here and what I want to quickly discuss is that again, whether you're a globe earth proponent or a stationary flat earth proponent or any other proponent of a particular model of earth, when we are now in a position of letting objects go or things apparently falling, whether you're a globe earth proponent or you are a stationary earth proponent, you are now going to require a force to bring your matter towards your earth. Okay? Now, the problem that we have is that if you pay attention to the one on the right here, that being in free fall, and the one on the left being an actual acceleration downwards, the one on the left detects the presence of a force. We have displacement. We have a reorientation of the matter, and as I showed earlier, when there's a force present applying a motion in a particular direction, the air will move towards the direction of motion, force. Again, I'm using those two words, they are synonymous, motion and force. Motion is force, force is motion. You must have something moving towards something else. The problem that they have is that if we look at this one on the right as it rolls, let's just see that again. Let's just pause there. On the left, we are witnessing the presence of a force. We are witnessing Marek applying force in a downwards trajectory. Because if you are going to assert that there is a downwards acceleration, a physical downwards acceleration, you require a force. Now, we do not have access to any sort of force, as I explained earlier, that can accelerate all various states of matter simultaneously like they were a uniform solid. This is taken from free fall, where proponents of particular models, stationary earths and globe earths, want to assert that there is now a force acting that can accelerate the solid, the gas and the liquid simultaneously in a downwards trajectory with no displacement occurring. We can see from the demonstrations on the left that is a preposterous proposition and blatantly false, demonstrably false. You can accelerate an accelerometer in any direction. The air will move towards the direction of the motion. Okay? These people are trying to claim and special plead and go into all sorts of outlandish propositions and beliefs and concepts and theories, about how this can now all accelerate from a stationary position towards the earth and no displacement occurs. This is because it is a visual interpretation of what is actually going on. Okay? Which we're going to slide into here in the next section of Marek's little video. So, in this position that you are within a reference frame, what is going on? This is moving up, this is moving down. This is the difference when you have only a visual interpretation. So people want to claim that there's downwards acceleration, which they only have a visual interpretation of. If there was actual downwards acceleration, accelerometers in all their forms would detect the presence of the force causing downwards acceleration. Marek's demonstrating for you here, So again, in this scenario here with the box moving, to you within the box, it appears that the ruler is the thing moving downwards. Again, that is only a visual interpretation. If you thought that the ruler was that thing actually moving downwards, you could attach an accelerometer, a basic one. You could attach a bottle with water and air in it. Or you could attach a digital accelerometer. You can attach any accelerometer you like to the thing that you think is actually accelerating. And the accelerometer will show you the direction of the force, the motion. So now we get to the really interesting parts where we can start, playing practically. We can demonstrate in any vector the creation of buoyancy and density. We can also invert buoyancy and density, that being we can reverse buoyancy and density, and we can achieve that in any vector. We can also increase the rate of the motion of the buoyant force or the buoyant effect. So this is just another little reiteration to highlight the point of this being a detection of a force, and when the force is present. Now, sitting static on the earth relative to you, you can already see displacement. You can see the air bubble orientated to the top here at the middle. Okay? And these are the variables that we start to mess with. So we've already seen that we can drop it from the earth and witness that the motion of the earth is now no longer felt through the bodies. The separation, the displacement is no longer there. Again, what we're going to witness here as we watch through the video is exactly that. That when force is present, which is in this case is going to be William pushing on this trolley, that is then transferred through all the matter and we see the displacement occur. You will see the air move in the direction that the force is going in. Let's just play through this here. As the force is now present, the motion, which would be William in this case, he is the force, he is the thing in motion causing this displacement. We see through inertia that we now have a compression within the vessel as the water wants to remain where it is. Okay? We see the compression happen towards the back here, and the air now travels in the direction of the motion, the force, which is William. If I now could blank out the two sides, you would only see that air rising. You would think this was sitting stationary on a table and that the air bubble was just rising like you witness every single minute of your life. Okay? You would not be able to tell. And the same is true right now as you sit and you watch air rising through a medium. Whether you have a glass on the table or whether you're running a bath and you see air bubbles rising to the surface, you are now witnessing the presence of a force, and that force is showing you the direction that it is travelling in. Again, we now can recreate a density layering on a lateral vector, that being perpendicular to the already established and present force motion vector. Okay, now we can see the density gradient being created. And as you can see, this wants to remain where it was. This now is being pushed forwards. Okay? This is because the compression of air towards the back is causing a more dense, and again I use these words very loosely, which is a later discussion, but for the purposes of this I'm going to continue to use the words density. Okay? We see a compression here, which in turn forces the helium forwards. So you're seeing a 90-degree, a perpendicular inversion of the conditions that you already exist within. Okay? Yes, and as William has highlighted here, motionless earth physics and globe earth physics, there must be a force acting simultaneously in two different directions. Again, human beings have never witnessed such a force, do not have access to such a force, cannot manipulate using any such force. We are messing with the variables here. We are applying practical physics to trying to comprehend the reality that we exist in. Every single aspect that's been shown here and discussed here in this video, you can recreate for yourself. If you are going to postulate some mystical force somewhere, that is your burden. Good luck with that. You're going to venture into Narnia. You're going to endlessly go around in circles trying to theorise and postulate and imagine how such a force could be. Not only that, you do not have access to it, you cannot manipulate with it, you cannot create any of the conditions that we are recreating for you by way of your imagined force. Force is motion, motion is force. We are demonstrating exactly the case. And again, William highlighting again the very same. The separation of the bolt, the nut, no longer coming here, and the air stops moving in that direction because William connected to the earth, the thing given the push, the motion, is no longer felt. The air cannot push the same as the solid earth can that surrounds this. So now you see the lack, the removal of force. Again, just another reiteration of the very same thing. Again, just another little aspect here. As we can see, as William is holding this, we have the compression, which is now causing the water flow from the perforated bottle. Okay, that is because the vector is upwards, which is now causing what we call drag. There's a resistance here as the liquid wants to remain where it is, which is now causing a downward compression and forcing the water outwards, only because it's attached to William, who is standing on the solid earth. And as you can see, that compression is no longer present. Now we are dealing with all sorts of outlandish nonsense. That the minute that William let that go, some mystical force surrounding us is now applying various amounts of force to now accelerate the solid, the gas and the liquid simultaneously, uniformly towards the earth. Again, we as human beings have never witnessed, nor will ever witness, such a force. It is only in the imagination, in the minds of men with a bias, interpreting the reality to fit a presupposed model. This is how you end up in nonsense world. When you ignore and you omit the practical, the real world, in favour of a presupposition. Clearly demonstrated that the compression, the pressure is now no longer felt, it is no longer present. If you were a being within that water, as William held it, and swam to the bottom of that vessel, you would feel an increase in pressure. As soon as William lets that go, the pressure immediately vanishes. The presence of the force is immediately gone.
A slinky will only stretch when there is a force being applied. You can test this for yourself. You cannot stretch the slinky without a force. This is something important to note, as it will make the following experiment much easier to understand. When we have a bottle with water and it's connected to the earth, we can experience weight and buoyancy, which are effects of a force or motion. For example, something that's more dense or heavier than the water by volume, like the slinky, will sink or appear to go down, and something that's less dense, like the ping pong ball, will get pushed to the top or float. If I glue the ping pong ball to the top of the slinky so it can be one unit, we can experience a density gradient. The more dense material at the bottom and the less dense at the top. Also, the fact that the slinky is being stretched shows that there is a force present when connected to the earth. However, as soon as I release the bottle into freefall, the buoyant force of the ping pong ball and the weight of the slinky completely vanish along with the density gradient. The slinky is no longer at the bottom and the ping pong ball is no longer at the top. Also, the fact that the slinky is not being stretched shows that there is no force present. Acceleration requires a force. No force in freefall equals no acceleration in freefall.
There we have a vessel, container of water, a measure, a slinky, a set of keys, and a ping pong ball at opposite ends of the slinky. Of course, the key is going to sink in water, and the ping pong ball is going to float. Let's observe what happens in freefall.
And some more examples, and the beauty of being invested in reality and accepting reality for what it is, there is no limit to the amount of practical testing and play. We can think of all various, ways to test. So these are just another few examples. this little one is just the same as the ping pong ball, where we have the ice wanting to float at the top, stretching the spring, and once removed into free fall, the only thing that's there present is the tension within the spring, which returns to its natural state and takes the ice deeper. Again, showing you that buoyancy and density are only the effects of the presence of a force. Without a force being present, that being motion, buoyancy and density do not exist. And in these examples, amazingly, the direction of a flame, the shape of the flame, dependent again upon the presence of the force, being connected to the earth given that its orientation and dictating the direction of the flame and the flame's shape. Amazingly, as you will witness here, what happens when in free fall to the flame. Sorry, accelerating down in this scenario. This is an inversion. Again, we're going to see other examples of this coming up very shortly, that we can invert the directionality, the orientation of not only the flame, but of buoyancy and density itself. And again, in any vector, 360 degrees, we can recreate this and show you how your reality actually is. As you can see clearly, as Andrew applies actual downwards acceleration, force, the flame shows the direction, again due to the compression of air, showing you the direction of the force, the presence of the force. And again, in free fall, when we have no force present, the flame has no orientation. And as Andrew catches again, you can see an initial burst as this is accelerated up to the constant speed of the reference frame. You see that acceleration as the flame is stretched upwards more. It's just an incredible sight to witness. Reality is really simple. The minute that we get complicated, theoretical, never-ending gibberish, we know we're dealing with falsity. Side-by-side comparison of actual physical downwards acceleration and free fall, which is claimed to be downward physical acceleration. That's not what's going on. And again here, more examples, again changing the direction, actual downward acceleration here, and you will see the air move in that direction. We will also now witness when we add to the upward vector and accelerate more in the upward trajectory, you increase the rate of the bubble rising through the medium. So in this scenario, and here is where Andrew now accelerates it towards the ground, and you will see the air now travel in that direction. Now we will witness the increase in the rate of the buoyant effect, that being the air bubble rising towards the sky. As we accelerate upwards, adding to the already existing motion vector, you will see the rate of the bubbles rising, increasing. The opposite, as you can see here, Andrew's marked it. Here, instantaneously in free fall, you can see that there's no displacement. The force is no longer present. As soon as we remove it from the earth, it's instantaneous. The only reason that there's a separation, a displacement between the various states of matter is in the presence of the force. That is coming from the earth in its motion. At the instant we let these things go into free fall, there is the removal of the force and the displacement is no longer present. So, now unfortunately for you, you have my ugly mush to contend with. So, I compiled that to hopefully give you a better comprehension of my position, our position, and why we are in the position that we are in. There's still many questions that I have, and I'm sure there's still many questions that you have, and we can discuss those things as we move forward. But it's beyond any shadow of a doubt that what we've demonstrated for you is that it's the Earth's motion that is the cause of the effects that we experience: a pressure gradient, a density gradient, and a directionality. The true motion vector is upwards relative to us as observers within this reference frame, upwards towards our feet. Okay, that's demonstrable. So now, if you still want to maintain a globular Earth or a stationary Earth position, or any other position for that matter, you now have to have some force that's capable of achieving uniform physical downwards acceleration. Okay, we have an appearance of downwards, but it's only visual. What you're witnessing when I let that go is a loss of momentum and the upwards trajectory, as we have demonstrated. You set a vessel of water on the table, you can see the air's at the top, water is displaced. Level is the perpendicular orientation to the true motion vector, which is the plumb, the vertical. We take straight lines 90 degrees from the plumb, and we apply that to practicality in the real world. These people that are claiming forces surrounding us, acting upon matter, are wishful thinkers. We can demonstrate in any vector the recreation of the conditions of our reality. We can isolate, we can change variables, we can alter the rate of displacement in any vector. We can increase the rate of displacement in the established vector, that being in that direction. So as we accelerate things upwards, we can see an increase in the rate of the buoyant effect. When we put these things in free fall, there is no orientation, there is no buoyancy, there is no density, there is no pressure. There is nothing. It's the removal of force. So once you comprehend that the Earth's moving uniformly and a constant, that should dispel any silly notions of absurd models of Earth like globes and stationary flat Earths. They are preposterous. You cannot isolate any of your propositions. You cannot use any of your postulations to demonstrate, to alter, to vary any of the variables in actual reality. You cannot invert buoyancy and density, you cannot increase the rate of separation, displacement of buoyancy and density. You cannot achieve any of that. So why, I ask the question, are you maintaining the belief? You have to ask yourself that question. I have given you ample practicality. If you want to try and argue against the practical, then your words are meaningless until you can qualify your position by means of practical reference, and you can alter and change variables and satisfy, and match the very same that we have shown you and given you, then you don't have a leg to stand on. And the naysayers and the people who are hand-wave dismissing must have an agenda, must have a bias. What we are showing you is accessible to every single human being alive. It's not a bias, it's not a belief. It's there for you to experience and witness for yourself. So, as we move forward, I always, invite any discussion. But if you have a position that you want to come and demonstrate, it must be practical. You must be able to demonstrate your position, as we have done and we can continue to do forever. I hope that it's offered you something and maybe gave you clarity on our position, because as I say, there is a knee-jerk reaction, there's an emotional, triggered response. Nothing has ever changed here at this platform. It has always been about the practical, always about the objective inquiry. Nothing has changed. The only thing that's changed is people's perceptions. And those people have to take a look at themselves and why they're operating from a bias. There's no shame in admitting you were wrong, and advancing yourself and moving forward with the new information that you have. And it's not just information in the format of rhetoric. This is information that's practical and demonstrable, that you can access, that you can go and recreate any one of these tests. If you're going to make statements and claims about forces and how they act, mainly uniform acceleration of gas, liquids and solids simultaneously with no displacement, no separation occurring, you must be able to isolate such a force. You must be able to demonstrate your force. You must be able to manipulate the test that we're witnessing, invert it, slow it down, increase it, just like we've shown. Until then, you don't have a position. Your position's based solely on rhetoric, conceptual idea, not practical, real-world physicality. The email's at the top for anybody that's interested and wants to get in touch with me. If you think you've got something to offer, I welcome it. I'm not interested in division, us against them. Reality's singular, it's objective. Okay? The bar must be practicality. If we do not have the bar set at practicality, we are inviting all sorts of nonsense. Hopefully this has helped to it. And again, I'm probably going to make more videos. There's so much that I want to cover, and it's very difficult to compile it all in one go. So as we move forward now, I've gave the base, foundations of the position here, and as we move forward, I'll elaborate on many other aspects of it. So hopefully that helped and gives a bit of clarity. Take care.